in today's lesson you will learn how to find a missing angle in an isosceles triangle, and you should be able to do this yourself by the end of the lesson. So what is an isosceles triangle? And this should be a little bit of revision for us. An isosceles triangle has two sides of equal length and one side with a different length. The fact that a triangle is isosceles tells us a little bit more about its angles. So here is an isosceles triangle, and we can see the lines mark the two equal sides. So this side is equal with this side. Now, because triangle PRQ is an isosceles triangle, it tells us that angle RPQ and angle RQP are equal angles as well. So that is the angles created between one of the equal sides and the unequal side. They are the same, and this applies to every isosceles triangle. So let's calculate missing angles. So here we have 38 degrees created between one of the equal sides and one of the unequal sides. So here the angle marked with a star must also be 38 degrees. In example 2, we have two angles to calculate. So let's start by finding the one that is equal to 46. This angle here is created between the equal side and the unequal side. So that means that the star angle is 46 degrees. If we want to calculate the question mark, we need to add what we know and take it away from 180. So let me add 46 with 46 to give me 92 degrees, and take that away from 180 to give me 88 degrees, which tells me that the angle marked with a question mark is 88 degrees. So in this question it's a little bit different. This time we've been given the angle between the two equal sides of the isosceles triangle, which means it is not the same as other two. It's in fact the angles that are marked with a star that are equal to each other in this case. So we begin by taking the 88 degrees away from the 180 degrees, and that leaves me with 92 degrees. Now I know that the two star angles are equal, so in order to find what they are, I need to share 92 equally between two angles. And in order to do that, I need to divide 92 by 2. 2 goes into 9 4 times with a remainder of 1, and 2 goes into 12 6 times, which means the missing angles marked with a star are both 46 degrees and they are equal. In example 4, this is pretty similar. We've been given the angle that is not equal to the other two, so we start by subtracting that from 180. And then I need to share this amount equally between these two angles because we know that we are the same. So I do that by dividing by 2. 2 does not go into 1, so we carry the 1. 2 goes into 14 7 times, and 2 goes into 0 0 times, which means my two missing angles marked with a star are both 70 degrees. Okay, this one's got a little bit of problem solving in it. Triangle GFH is isosceles. Angle HGT equals 125 degrees, so that's the angle we've been given. So part A asks us to calculate the size of angle HGF, which is our angle down here. Now, we can see that angles HGF and HGT are supplementary because they lie on a straight line. So, in order to calculate the size of angle HGF, I want to take 125 away from 180, which is going to give me 55 degrees. So now I know that angle HGF is equal to 55 degrees. Part B asks us to state the size of the angle HFG, which is this one over here. Now I can see that this is an isosceles triangle, so I know that HGF is equal to HFG. So I know that angle HFG is also 55 degrees. So in order to calculate the size of angle GHF, I add what I know and take it away from 180. So I'm going to add together 55 and 55 to give me 110, and I'm going to subtract that away from 180 to give me 70 degrees, which means that angle GHF is equal to 70 degrees.